We live in a world of invisible energy. Energy in the form of heat, which produces no visible color or light. It is this infrared energy that allows manufacturers of passive infrared detectors, like Central, to produce a PIR this small that can accurately detect the body heat of an intruder. Just as a camera takes in light, the PIR sees warm infrared images against a cooler background. Since it doesn't emit a beam, we call it passive. It is designed to alarm when it sees the image of an intruder, so it must be able to discern between an intruder and other sources of infrared energy. We'd like to show you how this is done. Through this heat-sensing camera, we're going to take you inside the world of infrared and let you see for yourself the effects of thermal energy. If the intruder was the only infrared image that the PIR could see, detection would be simple. But that's not the case. This forced air duct, for example, creates images on the wall by blowing conditioned air onto a surface of different temperature. The infrared detector doesn't see the hot or cold air, it sees the rapid change in temperature and movement as the air propagates across the wall and heats or cools the surface. The bold colors of thermal energy are what the PIR looks for, yet it must be able to distinguish between a false alarm source and an intruder. This space heater is another good example of a false alarm source. The thermal energy created by the heating elements is concentrated in a narrow band, producing an infrared image distinctly different from the cooler background of the room. This infrared image shows what the PIR sees, an image similar to an intruder. To ignore this event and avoid false alarms, the PIR must be installed properly. It's hard to believe that this harmless fellow could set off a PIR, but he's a serious false alarm source. Since rodents are usually on the move and they are warm-blooded creatures, they create an infrared image moving across the focal plane of the PIR. This infrared image shows the distinct difference in color between our rat and his background. If the PIR were not designed and installed properly, it could easily mistake him for an intruder. I am the reason you want your PIR to alarm. I've broken into your home or business. I'm an intruder. The PIR should recognize my infrared image as distinct from all others. It should see my human signature. Look at the image again in infrared. The thermal energy that I create may look like other heat sources, but I'm certainly taller than the rat, and I'm moving across the focal plane of the PIR. Your detector should be designed and installed so it will make those distinctions and keep false alarms to a minimum. The unseen world of infrared energy poses many challenges for the manufacturers of passive infrared detectors. To accurately detect the body heat of an intruder, the PIR must ignore other false alarm sources. It must include the most precise hardware and be designed using the most recent technology. It must be installed properly, and it must be able to read the human signature. Part 2 of our program takes us on a tour of the Central Sharpshooter, Central's highly accurate and best-selling PIR. We'll be taking a close-up look at the design and components that give the Sharpshooter one of the lowest false alarm rates in the industry. Come along with us as we take an inside look at this PIR. It's that simple. I walk in front of the PIR and it alarms. But what really goes on inside the detector? How does it know that I'm not a burst of heat? How does it read the human signature? Let's take a tour of a PIR. In this case, it's Central's Sharpshooter, and see exactly what happens when my image is detected. For a PIR to detect an intruder and ignore false alarm sources, it needs a clear image of the source of infrared energy. Before the pyro can respond to heat sources within the PIR's field of view, the infrared image must pass through the lens. This is Central's Fresnel lens, an opaque design that focuses the infrared image onto the pyro. The lens has been designed to filter out white light while gathering more signal energy than a mirror-based PIR. This advanced lens design decreases signal loss, creates a sharper image, and improves detection. Conventional Fresnel lenses use equally concentric circles or grooves. Central's lenses have a larger center section with the grooves spaced closer together as they approach the edge. This design is a big improvement in signal gathering. Since grooves on the outside of the lens can collect dust and dirt, degrading the image over time, Central uses a lens with grooves facing inside. The grooves are also cut into the plastic instead of rising above. This means less plastic for the signal to travel through and therefore less signal loss. The Fresnel lens, seeing the image and focusing it onto the pyro. The first step in the signal processing chain, and one that Central has improved for superior performance. Projecting a clear, sharp image is vital to the performance of the pyro, the next stop on our tour of the PIR. What is a pyroelectric sensor? It's the heart of the PIR. It produces an electrical output when subjected to a change in infrared energy. As the image through the lens is focused onto the pyro, it senses a change in temperature. If these temperature changes represent a human signature, the signal processing circuit will alarm. The sharpshooter uses a dual-element pyroelectric sensor and bidirectional pulse count for high false alarm immunity. Simply stated, for an image to appear as a human signature, it must pass in front of both pyro elements, one positive and one negative. The bidirectional pulse produced by a human intruder relies on these positive and negative elements to define the human signature. The pyro elements are electrically connected such that false alarm sources that appear on both elements at the same time are canceled. It's no accident that Central's sharpshooter has such a low false alarm rate. Their sensor is one of the lowest noise, highest performance pyros in the industry. Although most PIR manufacturers test their pyros over short periods of time, Central tests their sensors in extreme temperatures over longer periods. Since faulty pyros are the cause of popcorn noise, a false alarm source, testing their sensors over longer periods allows Central to keep poor quality pyros out of the field. We know that the Central sharpshooter is designed with better quality optics and the finest pyroelectric sensors. However, it's the combination of this efficient optical design and Central's signal processing that allows the sharpshooter to detect small variations in temperature. Since a PIR sees an intruder as a difference in temperature between the intruder and its background, if the temperature of the background is close to the intruder's temperature, it's harder to see the intruder. This footage was taken during the development of the Sharpshooter XT, the extended temperature version of the popular sharpshooter. As you can see, the intruder's image disappears as the room temperature approaches the intruder's temperature. Developed to solve this problem, the XT expands the temperature range at which it can see an intruder, making it a more effective PIR. Central's Custom Integrated Circuit, or ASIC, is the brains of the PIR. It constantly monitors the signal generated by the pyro until it identifies the human signature and sends an alarm to the panel. The ASIC is like a dedicated computer built into the PIR. Custom circuit components allow for a smaller, slimmer circuit board design, and fewer parts mean higher reliability. Since RFI, or radio frequency interference, is a common false alarm source, RFI filtering is built in. This jumper allows you to select one or two zone detection. Remember, each zone is made up of one positive and one negative beam. One zone detection is used for most areas. However, two zone detection should be selected for those areas where false alarm sources are known to be present. To prevent insects from getting to the pyro detector and to create an air pocket of insulation against hot or cold drafts, Centrol has sealed their detector and optics. Drafts and insects are both causes of false alarms. There is no substitute for quality engineering. The Sharpshooter has a custom integrated circuit with built-in RFI filtering, surface mount technology, and fewer parts for higher reliability. It has advanced signal processing, combining bidirectional pulse count and event verification, allowing you to choose 1 or 2 zone detection. Centrol's pyroelectric sensor is one of the lowest noise and highest performance pyros in the industry. The Sharpshooter's sealed detector and optics are insulated from drafts and kept free of insects. The advanced Fresnel lens design outperforms the conventional Fresnel designs, as well as mirror optics. It also filters out white light, a cause of false alarms. It's clear that Centrol has taken a leading role in the development of the PIR, with the best-selling Sharpshooter having one of the lowest false alarm rates in the industry. Part 3 of our program looks at Centrol's entire line of PIRs and their applications. Let's take a look at how to apply PIRs in the world of infrared.